You're going to do it. Where do I start? What can you tell me about number one? There is no power. What happens? I'm going to give you a different way to see the answer as well. Will it pass current or will it block the current?
It will pass.
Pass. Then I draw a line there. You can pass current. So where do I go?
2.
Number 2. Number 2 is normally closed. It's got power. What will it do?
Go down.
Will block the current. So where do I go?
4.
Number 4. Number 4 is normally closed. It's got power. What does it do?
6.
It goes open, so it blocks the power. Where do I go?
6.
Number 6. Number 6, normally open. Power on. It will close. It can pass the current. Where do I go?
3.
Number 3. I go to the top. Number 3, normally open. No power. It will block. Then I go to number 5. Number 5, normally open. It's got power. It will pass. So I reach the output. The answer is 1. Now can you see where the current is going to flow? It's going to go there, 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 to the output. That is where the current will flow. This person that said, when I asked where will you go to, when I said it will pass here, the person that said you go to 5, you will get the same answer, but you left out the 3, minus 1 mark. You must give me the exact order of the logic. Okay? Right. Give me numbers. Give me numbers. 0, 1, 0, 1, 0, 1. Okay. 0, 1, 0, 1, 0, 1. What will that produce? If you want to use this way, do it in pencil, then when you finish with the first one, you rub it out. You rub out those marks. Then you do the next problem. You start with number 1. It is normally closed. No power. Current can pass. Go to number 2. Number 2, normally closed. Power on. It will go open. Block. Then I go to number 4. Number 4, normally closed. Power on. It will block. Go to number 6. Number 6, normally open, power on, it close, it will pass. I go to number 3. Number 3, normally open, no power, it blocks. Then I go to number 5. Number 5, normally open, no power, it will block. I cannot reach the output. Answer is 0. Have you got it? You are writing tomorrow, on Monday. Is it right?
No.
Oh no, you're writing next week. Next week, Tuesday. Huh? 9, 10, 17. Yeah, that is not this coming Tuesday, it's the next Tuesday, yes. Right. I want you to refer you to page 67. Page 67 in the book. There is one similar to this with 6 problems. Go and do it on your own. See if you are happy with it. Because this is definitely a test question, it's definitely an exam question. Let me just do a very complicated one here quickly. Number 3. And let me just turn all of this around. 1, 0, 1, 0, 1, 0. What is that one? We start with number 1. Number 1 is normally closed. There's power on it. It blocks. I must go down. Where do I go? Nowhere. Answer is 0. Huh? You see it? Huh? If it blocks here, if it's going to block here, current cannot pass here. Is there any way I can get to the output? No, then the output will be 0. Because I must go down. I've got no logic down here. If I change this line and I put that line here, then it will go to 6. You see it? Then it will go to 6. But that line is not there, the line is there. Then the answer is just that. Start with number 1, output is 0. But if I make that modification, this will go to 6. And then 6 is normally open, no power. There's nothing down here. Answer is still 0. But now it is 160. Okay? Who wants to give me some numbers? If you're happy, I'm going to step off this and just introduce the next piece of work. Right. What I want to introduce to you is the rest of this chapter. I'm not going to do the first design today, but the rest of this chapter is designing the logic for the PLC. In chapter 2, we designed the logic for relays and solid state. Now here we are designing for PLCs. The design we will do, the first one, will be the same designs we used in chapter 2, not all of them. We're basically only going to do 2 designs. We're going to do the design of the machine cut into grooves, and we're going to do the design of the machine drilling 2 holes. Only those 2. But, I can give you a totally different picture. I can combine them. I can say, there's a job. I've got one cylinder here, which has got a cutting tool. And this is going to cut a groove. And I've got another cylinder there, which is carrying a drill. And it must drill a hole there. Going to drill a hole here. And then I will have a switch at the bottom here, a switch at the top there, a switch on that side there, and a switch at the back here. Now I say, that is switch 6. This is switch 9. That is switch 4. This is switch 2. This is cylinder P. This is cylinder Q. And then I've got a start button. And now I give you the logic in a paragraph. And immediately I can have two things. I can say, when I press the start button, then cylinder Q cuts the groove. Or I can say, when I press the start button, drill A goes down and drill a hole. Okay? So I can start off two different ways. Now I can do the next. I can say, right, when I press the start button, cylinder Q cuts the groove. When it touches switch 9, I've got two possibilities. I can say cylinder Q comes back, or I can say then cylinder P must drill a hole. So on that sketch, I can, by changing the order of the question to different types of logic. And it is very, very important, doesn't matter which sketch you get, when you just look at the sketch, even before you start reasoning about the question or reading the question to find the logic, you must first do one thing. And that is to look at that and say which switch or switches are closed in the beginning. Now, it is not shown on the sketch, but there are two switches closed in the beginning. Which two will that be? Switch 2 and switch 4. Why? Because there's an arm here which presses against it. So if this one is back, switch 2 is closed. And there's an arm there that is going to touch switch 4 and 6. So switch 4 is closed in the beginning. When will switch 4 go open? It will go open when cylinder P starts moving down. When will switch 2 go open? When cylinder Q starts moving to cut the groove. What I'm trying to tell you is when you read the question about the logic, get the whole picture in your mind, understand how that machine operates. And the very first thing which counts marks is I ask you, give the logic statement of the machine. That is always the first question. And where do you get that? You get that from the description that I give you of how the machine works. So if I say, when you press the start button, Q moves. That logic will say start, then Q will be moving. Now you can see it's going to touch switch 9, but it will be written in the document there. If it touches switch 9, then, so it's going to touch switch 9. Then, what do you want it to do? Come back or start from the cylinder P? Huh? Let me just turn on still busy. Hallo Jolita, ek staan in 'n klas. Huh? Jolita? Hallo? Okay. That was a pocket form. You know a pocket form? Right. My sister called me with a pocket form. Right. What do you want to do? P or B go back? Q go back? Huh? Q goes back. Okay, then you will say P goes down. Then I will say it's going to touch switch 6. Right? Now, if it touches switch 6, two possibilities. P can go back or Q can go back. Which one?
Q.
Q goes back. Okay, then Q goes back. Sorry, touches switch 6. Then Q goes back. And then it's going to close switch 2. Right? And then there's no other possibility. P must go back up. But can you see, that logic will change every time I change the story about the operation. Now, why did I say it's important that you check which switches are closed in the beginning? Do you see switch 2 there? Yes, there is switch 2. I look at the logic. What is the job of switch 2? To make P go back. Right? Where is P at the beginning? It is on top. So there's no problem with switch 2 being closed. What about switch 4? Oh, I don't see switch 4 there. It's not part of the logic. So it doesn't matter. This is one type of design, and I'm going to discuss that starting which our next class? Monday. I'm not going to do it now, I'll do it on Monday. There are only two types of designs. The one where the switch that is closed in the beginning causes a problem. The other one, if the switch that's closed in the beginning does not cause a problem. And those are the two types of designs I'm going to discuss with you. And you will get one of those two types of designs in the test. So, I'm going to start off on Monday without doing anything like this. I'm going to start off with a machine cutting 2 grooves. And I'll show you step by step how we do the design. Because we do the design from this. We use that to do the design. And then I will do the machine drilling 2 holes. The one has got a problem, the other one don't have a problem. You remember in chapter 2, with that machine drilling 2 holes, we had to include the line. Remember, switch 1 was touched. That is the one with the problem. I will point it out to you Monday, Tuesday next week. Go and enjoy your weekends.